We have a last speaker and then it's time for the coffee break. Okay, I see now. Jan Winter, DB Energy, on the 9930 and the data exchanges on ground.
Yes, thank you, Bart. Yes, okay, thank you. So, my name is Jan Winter. As Bart mentioned, I'm from DB Energie. DB Energie is infrastructure manager for the energy part in the railway sector in Germany. And at DB Energie, I'm responsible for the data flow from UIC CBD data exchange to energy use settlement. And I'm engaged in UIC data exchange at DB Energie for 2 years now. And I'm one of the representatives for DB Energie at the UIC IRS 9930 working group. The UIC IRS 9930 is a working group, and most of the members are infrastructure managers from Europe, with the aim to do a sustainable implementation of the IRS 9930, and the main focus is the CBD data exchange. We have to be in line with Senelec standards like the EN 5463 and also ERA TSIs like the TSI lock and pass. The IRS 9930 is, so to say, the successor or the replacement of the Leaflet 930 from 2009, and it complements the EN 5463 2017, which is basically that's the base for the IRS 9930. What are the challenges and perspectives regarding the IRS implementation? We have to make the compliant the on-board to on-ground communication, from EMS to DCS to the on-ground to on-ground communication from exchange to exchange. Therefore, we have to respect national regulation and restrictions. Many of the members are in the European Union, but nevertheless there is quite a diversity in regulation and restrictions for energy market and for the railway market. And we have to align and come to a homogeneous international European solution, despite the diversity of the IT levels at the different members. And we have to make the standard adaptable for every actor, the actors who are integrated now, but also for actors who are maybe joining the project later on. And we have to develop and using and implementing a product while there are still some open points to solve. And we need a very close cooperation and to have a common and mutual understanding to do that fully operational. So let me show you an example for the data flow that is from between France and Germany. That was created by my colleague Darren and two colleagues from France, from RTE and SNCF. So now we have a train run from France to Germany, and on the train there's installed an EMS compliant with EN 5463 2017, or the typo. And now, that's a train run. And the train, the CBD data is reported to the DCS in France, cooperation between RTE and SNCF over there. There it's going. And now from DCS to exchange system, there's the allocation and validation, allocation to the right infrastructure and country. So we have built up polygons around every country, so we can allocate the CBD data to the right infrastructure. And then the part in France is used for the energy use settlement in France, and the data in Germany is going to the exchange, and that is on the SFTP protocol, and is going to the German exchange system from DB Energie there, and then we do a check up and acknowledge the message. It's either a positive one or a negative one. For example, if we are missing master data, then we send a negative acknowledgement with a specific error code, so the other part, the sending part, knows that they have to send the master data. And then acknowledgement, and yes, then we use that part to the energy use settlement from DB Energie and doing the invoice against the vehicle keeper or railway undertaking, and also the same process vice versa. So for a train running from Germany to France with a German EMS, it's the same way back. So I have a real data example. Here we have a ICE3 German high-speed train running from Frankfurt to Paris, then to Stuttgart, back to Paris, and finally again to Frankfurt. So the CBD data in Germany is used for the energy use settlement in DB Energie, and the part in France is sending to the UIC exchange operated by RTE in France, and they use it for their energy use settlement then. And no detailed view into that. So if you know the EN 5463, it will look quite familiar to you, because we are using the XSDs from the EN 5463. So we have the source 80, that is Deutsche Bahn, and then we have the 5158, which is RTE, the exchange partner in France. Then over here we have the National Vehicle Register, the VKM, Deutsche Bahn, and the EVN 9380, so a German ICE. And over there we have the first interval with tracking system unknown, energy active and reactive with quality 127, so measured, and location also 127. Other possible codes are 61. If it's exceed the max power, it will be set to 61. And also for the location, other possible quality codes are 61 if it's exceed the max speed, or 56 if there was done a interpolation because there was a tunnel, for example. Deutsche Bahn is in exchange with RTE and SNCF since April 2023. That was, they were the first partners for Deutsche Bahn for the XML exchange based on the IAS 9930. Then the next ones are SZCZ from Czech Republic, and at the same date we are also started with SBB Infra from Switzerland. They are a member of the ERIS partnership, and since September we are in exchange with Infrabel from Belgium. They are also a member of the ERIS partnership, and testing with PGE, who is they are the infrastructure manager for Poland, starting the next days. And we are still in exchange on the old protocol, to say, and UTLTS EDIFACT standard with ÖBB Infra from Austria. They planning to switch to XML next year, and we are also still in UTLTS exchange with other ERIS partners, and ERIS plans to change also in the next time. So what is the status quo? Deutsche Bahn, DB Energie is exchanging incoming about 100 CBD messages per day, and outgoing it's about 150 to 200 messages per day. Now implemented is also acknowledgement that I mentioned before, and what I said, negative acknowledgement are handled by receiver, for example, missing master data. The master data exchange today is handled by a CSV, and in 2024 we are working on automated XML master data exchange and also on request response messages. Yes, that's it. Thank you.